Last time, we'll go through, I don't know, at least part of this. So for the first one, it is cosine x equals 0.37. How do I get the x by itself? Yeah, I do cosine inverse to both sides. Good. And then I think I told you to do the odds as degree and then the evens as radians. So when I pull out my calculator, the mode I'm going to make sure that I'm in is degree. So I am set in degree mode. And then we'll do cosine inverse of 0.37. So one answer I get is 68.3 degrees. One is fine. Yeah. So here is one of our answers, right? But I know that all silly turtles crawl. So cosine is also positive in the fourth quadrant. And I know that this distance is 68.3 degrees. So the angle that I'm looking for is 360 minus 68.3 degrees, which is 81.7, right? Yes. So those are my answers inside of 360, but it wanted all the solutions. So what do we have to do to each of these? We just write that plus 360k thing at the end. And now we have all of the solutions. Is it 91? Okay, thank you, Sophia. Julia, to answer your question of how you know you're looking for another answer, is between 0 and 360, like if I have this value where we have x comma y on my unit circle, right? If I go directly down, that same x value also occurs down here. You know what I'm saying? So this is a second solution for that value of cosine. So there's a second angle that gives you that value of cosine. Almost always there's going to be a second solution. The only time where there might not be a second one is if you're dealing with like a quadrantal angle or something. Sure. It'll probably happen a little bit more today when we do some examples today where we look at a little bit more difficult solving problems. Where the solving process becomes more difficult, but this sorting out your answers still stays about the same. But we'll see another example of that. All right. Rather than changing my calculator's mode every other time, I'm just going to do all the odd ones here first, and then we'll come back and do the even ones after. Sound good to you guys? Good, you didn't have a choice. So the next one, sine x equals 0.30. First thing I want to do is sine inverse. get that x by itself. And since this was an odd problem, I asked you to give your answer in degrees here. So I'll just go to my calculator and do sine inverse of 0.3. When I do that, I get 17.5 degrees. But I know that's not my only solution. So 17.5 degrees is here. But sine, I know all silly turtles crawl, is also positive over here. And I know that this angle here, its reference angle, is still 17.5. So this angle is going to be 180 minus 17.5. So my other answer is 162.5. So those are my answers inside of between 0 and 360. To extend that to all solutions, I just tack on a plus 360k. Yes? No? Yeah, I'm not going to come back and ask you to do that again for these ones. I mean, I'll give you new problems. Yeah, fair question. So 67 now is a little bit different. There's something we need to do before we can do the cosine inverse of both sides. What's different about this one than the previous ones? It's cosine squared. Remember that cosine squared really means that. So how do I get rid of the squared? Square root. When I square root both sides of an equation, what do I need to remember? Plus or minus. So let's do the square root of 0.4. So that's 0.6 yada yada yada. So this now, to do the cosine inverse, I'm going to have to break up into two separate problems. One where I have cosine x equals positive 0.632, and one where cosine x equals negative 0.632. Everybody okay there? Now let's do the inverses. Yes. So that's what I just typed into my calculator. So now we'll do cosine inverse of that value. So I got 50.8. Is what? I'm sorry, is it? We do have a question?
No,
Oh. Okay. Fair enough. So we have that. Now let's kind of draw our picture And I'm going to draw a separate picture for each one of these little problems. So here's 50.8 degrees. And since we're dealing with cosine, I know cosine is also positive in the fourth quadrant, where that distance is 50.8. So my other solution there is going to be 360 minus 50.8, or 309.2. So there is one set of answers. Now I'm going to draw a separate picture for the other part. So here is 129 degrees. And I know cosine is also negative in the third quadrant. So this piece right here is 180 minus 129.2, or 50.8. So this piece is also 50.8. And my other solution is going to be 180 plus 50.8. Everybody okay there? And then I just convert these into infinitely many answers by putting the plus 360k on them. So far, so good. For this part right here. So if you look at the angle that I've drawn, I've gone 180 to here, and then 50.8 more. Whenever we draw our angles, we always start from the positive part of the x-axis. Yep. Again, remember when we drew our angles, that was called the initial side, right? When we drew our angles on the xy axis, one of the first things we talked about when I took over was kind of going back and re-vocabularizing, just to make sure we were all on the same page with the vocab that I like to use. So yes, that is always starting there. And if we're looking for stuff between 0 and 360, we're always going like in that counterclockwise direction. Okay. I didn't hear your mumbling. Okay. So let's do the evens now. So first step should be cosine inverse of both sides. And now I'll pull up my calculator. What do I have to remember to do this time with my calculator, though? Yeah, we got to change the mode to put it into radian mode. So I'll do cosine inverse then of 0.75. And the answer I'm getting now is in radians, so it being a weird-looking decimal is perfectly fine. And I forget what that... I'm going to do 3 decimal places here. Everybody okay there? So let's draw my picture and figure out where that other solution is. So remember, this was like 90 degrees, but in radians that's pi over 2, and pi over 2 is like 1.57. So this guy is still in the first quadrant. Is everybody okay with how I kind of came up with where to put that? Okay. The other place where cosine is positive is in the all silly turtles crawl fourth quadrant. And I know this angle has to be the same as its reference angle. So this spot here, before when we did it was 360 minus that angle, but since we're dealing with radians, it's going to be 2 pi minus that angle. I can't do that in my head, so I'm just going to fire up my calculator and ask it to do it for me. So I got 5.560. And then I just slap on the plus 2 pi k's. Sophia? So I think what Sophia is asking is if we did all of this and everything spat out as degrees, could I take those degree answers like we had in the beginning, like for number 63, and then just do the radian conversion at the end? And if that's okay, that should be fine. Yep, that'll give you still the same thing. I just figured one less step, but if you're more comfortable doing everything in degrees and converting at the end, that's perfectly fine. No problems. It's a acceptable method. This drawing, so I will tell you that if I see this and can kind of see what you did and why you made a mistake, you're very likely to get much more partial credit than if I can see nothing and I can't figure out how you made a mistake. So again, does it have to be there? No, but it just takes a second, and if I can see what you did, I can certainly give you credit. Yeah, that's fine. I just want to be clear about, like, you should put it in there because it's good practice. Do I need to see it when I look at your homework? No, but you're definitely going to want to do it come test time so that I can, if you make a mistake, there's reasons I can give you points even if you have the wrong answer. If all I have is a wrong answer, I can't really do much with that, right? Okay, so tan x equals 5, first step. Tan inverse. Okay, and we'll fire up our calculator. Tan inverse of 5 is 1.37. I guess we said we were going to use 3 decimal places. 373. And then we'll draw our picture. So remember we said that this spot is like 1.57. This is 314. This is like 471-ish or something, and this is like 628. Just to give you, that's just me converting 90, 180, 270, and 360 into radians. So basically it's pi over 2, pi, 3 pi over 2, 2 pi, just as a decimal approximation to kind of give us an idea of where we're at. So 137 is still in this quadrant. And from All Silly Turtles Crawl, I know that tangent is also positive in the third quadrant, where this is still that same 1373. So here to here is pi, and then we'll add that 1373 more to get that angle. Everybody good with that? Okay, so I'll do that on my calculator. Pi plus that last answer. So 451.5. I don't know why I said 451.5. It's 4.515. And then we just turn that into the infinitely many situation. This, though, is a problem where you had opportunity to get extra credit. What do you notice about the distance from this answer to this answer? Yeah, they're pi apart. So I could really just write this as that. And if you do that on your test, instead of listing them two separately, if you combine them together into one answer when that opportunity arises, again, I would give that as like bonus points or something if you catch to do that. If you don't do it and you left it the way I did there, it's still full credit. So it's just as a bonus there for those of you that were paying extra close attention. Went, wait a minute, I can be a little bit more efficient than that. And now our last one, sine squared equals 0.4. First step should be, yes, Bella? You may. Square root both sides. What do you got to remember when you do that, though? Yeah, plus or minus. And I remember from earlier that the square root of 0.4 was that 0.632, I think. Now we can sine inverse of both sides, but we have to do it as two separate problems. Oops. I forgot my x. So sine inverse 0.632, and I get 0.68. I keep forgetting that I want 3 decimal places. 4. And then let's do that other one right quick. And I get negative 0.684. So let's deal with this first one first. So again, all silly turtles crawl. Sine is also positive in the second quadrant. I know that this reference angle is the same. So the angle I'm looking for is going to be 180 or pi minus that angle 0.684. Oops. I didn't even remember the 4, 5, 8. Okay. And then I can just tack on the 2 pi k's there. Now, look at this answer. What's odd about this answer? It's negative, right? So that's this. The value we want, though, is this one, right? So that's 360 minus, oh, I'm sorry, yes, 2 pi, thank you, Megan, minus that 0.684. So let's write it that way. And again, I'll use the calculator to get that. So 5.599, and then I might as well stick my 2 pi k on there while I'm at it. Everybody good there? The other place where sine is negative is here. I know that this distance is still that same reference angle. So my angle from here to here is pi plus 0.684. So that's 3823. So there's my 2 sets of answers. And did we mention on when we did the cosine that this was an opportunity to do the extra credit thing again? No? Same thing applied there, but there was, if you look carefully, you'll notice that this guy and this guy are 3.14-ish apart. So I could combine those two into 1 by doing plus pi k instead of 2 pi k. Similarly, if I look at this one and this one, those are about 3.14 apart. So I could combine those two into 1. And again, if you don't notice that or you're not sure that it's correct or whatever, don't do it. Not a big deal. You still get full credit if you had the things that were circled in red above. This would be like the bonus point question or answer, the extra credit version of the answer. And we could have done the same thing up with the cosine squared problem from before. I just overlooked it, I guess. You're talking about this piece right here, because sine is negative in quadrants 4 and 3. It was all silly turtles crawl. Okay. Let's do another problem. Where we make things a little bit more difficult by having more than one trig function into the same problem. The box with the answers. Oh, I was like, I boxed the answers there at the bottom. You're talking about a different set of answers. Actually, I take this back. I am not going to start with this one. I think this is probably harder than I want to for my very first example. Let's do this. Let's say we have cosine squared x minus cosine x equals 0. Let's do that as my first one. That other one, I think were too many things going on there that I didn't want to deal with right away on our very first problem. So here you notice we have more than one kind of trig function. Does everybody see this? So we have a cosine and a cosine squared. So what I want you to think about when we see a problem like this is I want you to think about the quadratic equation x squared minus x. If we were trying to solve x squared minus x, how would you solve this? You'd factor off an x and write it as x times x minus 1 would be the first thing you'd probably want to do, right? So what are we going to do to cosine squared minus cosine? We'll factor off a cosine and make it cosine times cosine x minus 1. Okay there? We'll then apply the zero product property. So I take one factor and set it equal to 0. And then I take the other factor and I set it equal to 0. Everybody agree with that? Sound familiar? You did this a bunch in Algebra 3-4 last year. So on this side, what am I going to do? I have cosine x equals 0, and I have cosine x minus 1 equal to 0. Everybody agree with that? Now I can solve each one of these two independently. So if I take cosine inverse of both sides, and if I go look at my unit circle, I know cosine 0 is a unit circle value. Where does cosine equal 0 at? Pi over 2, and also 3 pi over 2. Everybody okay there? I'm then going to do the same thing on this piece, so I'm going to add 1 to both sides. And then we'll do cosine inverse of both sides. And notice 1 is a unit circle value for cosine. Cosine equals 1 when x is 0. Does it equal 1 any other place on the unit circle? Again at 2 pi, but if you look, is 2 pi included in my solution set? No, right? So we just have the one answer there. So that's that one. How was that? That's it. Again, we only asked for the answers between 0 and 2 pi. And since these were all unit circle values, I could go straight to the unit circle and just read off the appropriate values, and I didn't have to use my calculator at all, which makes life a little bit easier, right? Oh, if that was there, then you'd have another answer here at 2 pi. Yes. Or if it was negative infinity to positive infinity, you'd write them with the plus 2 pi k's on them. So if I go to my unit circle, Why are you not? Oh, there we go. So cosine is which coordinate on the unit circle? X. So I go and find the places where x is 0. That happens at pi over 2. And if I go around, x is 0 again here at 3 pi over 2. So if I want to do cosine inverse of 1, I'm going to look for where the x coordinate is 1. That happens here at 0. And then if I follow it around, it doesn't happen again until I go a full time around again at 2 pi. Okay with that, Julia? Okay. So again, before I whip out my calculator, I'm going to look at my unit circle and just check to see if the cosine or sine or tangent values are unit circle values, because it makes my life a little bit easier if I'm able to use the unit circle instead of the calculator, because I don't have to draw the picture. The picture is kind of already embedded on the unit circle, and for sure you'll get a unit circle to use to do this. Does that feel okay? We have 5 minutes left. I don't think I can start and finish another example in that amount of time. Let's stop here. I don't have anything for you guys to work on tonight.